Hey, amazing people. What we're looking at now is we're looking at quantiles. Now, quantiles are certain points which we want to find underneath our generally our probability density functions here. Okay, now there's three main ones that we need to look at here. Those three we need to look at are going to be quartiles, which are the first one we're going to look at. Then, in addition to that, we're then going to look at percentiles and deciles as well. Now, quartiles, this is where you're breaking it up into quarters. And so you might remember from statistics, there's three types, in particular, which are of importance. We've got Q1, and this is generally the lower quartile or lower quarter of the data. You've got your Q2, which is generally the middle point here. So this is your median. And that one is particularly really special and important. And then lastly, we've got our Q3, which is our upper quarter here that we need to be able to find. Now, these are the main ones we're going to be dealing with, but there are the other ones as well. There are percentiles. Now, this is where you're finding a percentage. So it might be 1%, 2%, or 3%. So as an example, if you had a 72nd percentile, what you're doing in this case here is, as you work this out, that's going to be equal to 0.72 in your probability density function. Just to go back to the quartiles, well, the first one for the lower quartile, that's going to be 0.25. The median is going to be 0.5, and the upper quartile, well, that's going to be 0.75 here. Now, in addition to those two, we also have our deciles. Now, deciles is where it's broken up into parts of 10. So generally you're going up by 10% increments here. So for example, if you were dealing with the first decile, that would be equal to 0.1 because that's 10%. Okay, if you had one where you were finding the 8th decile, in that case here, that would be 80% because you're an eighth of the way, 8 over 10 of the way up. And so that would be 0.8 that you're seeking to find here. Now, if we look at this graphically, in particular, this applies to when we're finding the median. What we're seeking to find, if here's our probability density function, what we're seeking to do is we're seeking to find the middle part of it here, which is at this point here, which is halfway between our opening boundary of A and our closing boundary of B. And so what we're doing here is we want to find this middle point here, and this is going to be our median or our Q2. And so that's what we're seeking to find here. Now, the key way we're going to go about this is we're going to use the probability density function in a special way. The way we're going to use it is we're going to, particularly for the median, this is going to be where we're doing between A and X, being that middle point there of f of x, dx, and this is going to be equal to 0.5. So in many ways, it's a little bit like the cumulative distribution function as well, where we're trying to break it up into another part and then solving it to find what that middle value is. And so that's what we're seeking to do here. From this example here, we're told a particular continuous random variable x has the following probability density function. In this case, we're told f of x is equal to x over 16, and this is for the domain of between 0 and 4 root 2. And then we're told that for all other values of x, that it's going to be 0 for those points. Now, what we're seeking to do here is we want to create our integral here, which is going to be between 0 and x. We want that midpoint. There's going to be x over 16. But what we're going to do is we're going to say that this is equal to 0.5. The reason we're doing that is because we're finding that middle point. Remember, under a probability density function in PDF, the area under that curve is always 1, representing 100% all the possible outcomes. We want to find the median, the middle point. Well, half of 1 is 0.5 or a half. So that's what we're seeking to do here. So in many regards, rather than 0.5, what we might do is change that, and we'll use a half in this case. So as we go ahead and integrate this now, what that's going to give us is x squared over 32. Okay, and that's between x and 0 still. That's going to be equal to a half. If we substitute this in now, we're going to have x squared over 32, as we substitute an x value, minus 0 squared over 32. That's going to be equal to a half. But because of the 0, that basically goes away. So from this point here, as I seek to be able to solve it to find it for x now, I'm going to multiply both sides of this by 32 to tidy it up. We end up with x squared then is equal to 16. It's 32 divided by 2. And then I'm going to have a value of x is equal to 4. Now, the reason here is I'm only taking the 4. Yes, it is another possible answer of -4, but I have to think back to what my domain is. My domain is between 0 and 4 root 2. So it has to be a positive value, and it has to sit somewhere within that domain. And in this case here, for that to occur, I have to use the number 4. -4 doesn't sit under there, and so that's where it has no justification. So therefore, my median is equal to 4. And we have another example here now where we're told a continuous probability distribution is defined as f of x is equal to x to the power of 4 over 11,605. And this is for the domain between 4 and 9. And that for all other values of x, that's going to be equal to 0. And so from this, we're asked to find 3 things here. 2 decimal places. The first one is the first quartile. So this is Q1. Now, if it's the first quartile, that's going to be equal to 0.25. Next up, we're asked to find the 38th percentile. When we're doing that, that's where we're going to seek to find 0.38 when we're working this out. Lastly, we're asked to find the 7th decile, and well, this is going to be 0.7 when we're calculating this. Now, before we do anything else, what we need to do is we need to find out what the CDF is first. And so in this case here, we're going to have f of x. That's going to be equal to, and I'm going to factorize as I set this out for my integral. It's going to be between 4 and x, and it's going to be x to the power of 4 dx. So as I go and integrate this now, I get 1 over 11605, and this is going to integrate to give me x to the power of 5 over 5. Okay, and that's going to be between x and 4. So now as I start to substitute everything in here, I'm going to have, again, 1 over 11605. I'll deal with that in a sec when I expand these brackets. 1024 over 5. Okay, and expanding these brackets here, a bit more room, I'm going to have f of x is equal to x to the power of 5 minus 1024, and that's going to be all over 58025. So what we've got here is this is our CDF, which we're seeking to use here. So now what we're going to do is we're going to break each of these into parts. So let's start with A, first quartile. So what I'm going to do is we're going to have this equal to 0.25. So I'm going to have x over 5 minus 1024 over 58025. That's equal to 0.25. It's now just a matter of solving this algebraically here. So as I go through this process, that's going to become 14506.25 is equal to x to the power of 5 minus 1024. Keep going and rearranging this. I get x to the 5 is equal to 15530.25. Typing this into a calculator and working it out, I get 6.89, and that's to 2 decimal places. Okay, so our Q1, or our first quartile, is equal to 6.89. That's the first part of it done. Okay, moving on to part B, finding the 38th percentile. Again, it's the same process. I'm just making the whole CDF. So x to the power of 5 over minus 1024 over 58,025. This is going to be equal to 0.38. So again, let's just, using our algebra to rearrange and solve this, I end up with 220949.5. And again, make x on its own, that's going to be 23,073.5. And lastly, when I find the answer now, after I find the root of that, I get 7.46, and this is again to 2 decimal places. And so the 38th percentile is equal to 7.46. Okay, now lastly, moving on to our 7th decile, again, same process. So we have x to the power of 5 minus 1024 all over 58,025 is equal to 0.7. As I seek to arrange and solve this algebraically, I get 40617.5. Move the 1024 to the other side, I get 41 641.5. And as I find this out now, I get 8.39 using my calculator, and I get that 2 decimal places. So the 7th decile then is 8.39. And that's how we go about finding these different values, which we're asked to find when using a PDF and a CDF.